In this video, we're going to look at an old free response question and some added things that I put in there to just kind of think about. It says, let R be the shaded region bounded by the graphs y equals the square root of x and y equals e to the negative 3x, and the vertical line x equals 1 is shown in the figure above. Now, I have also brought in this graph that I might even just kind of post above it, since we know that R is that shaded region, and then in this graph at least we have all the intersection points. You would probably use your calculator to do that, but now we have them. Okay, so finding the area of R, I'm going to put A up here. The area, of course, is just the integral of the top function, which was the square root of x, minus the bottom function, which is e to the negative 3x dx. And the bounds looks like 0.239 to 1. And you could use your calculator to get that answer. Important to note, we could also do this one by hand. We could easily do the antiderivative of this, rewriting it as x to the 1/2, raise the power, we'd have 2x to the 3/2, and negative 1/3 e to the negative 3x. We could do those antiderivatives pretty easily by hand. Okay, find the volume if it's rotated around the line y equals 1. So we're rotating around this line y equals 1 like this. So we're rotating up. We're going to have both pieces rotated up around like that. Again, if you have forgotten how to do that, you might want to look back at some early integral videos and take a look at how this is going to work. But I'm going to have pi multiplied by 0.239, the integral from 0.239 to 1. My large radius is going to be 5 minus e to the negative 3x. And I would square that because I'm doing the area of a circle. So pi r squared minus 5 minus the square root of x squared, like that. Okay. Again, I want to go through this pretty quickly. If you've forgotten how to do that, I would recommend you look back at some older videos that I've made on kind of beginning volumes. Okay. Now, it's the base of a solid. Cross section is perpendicular to the x-axis as a rectangle whose height is 5 times its length. So we're building rectangles perpendicular to the x-axis, so like this, and they're being built up off the curve. So part C, I'm going to just draw real quickly a rectangle. The area, of course, of this, since the height is 5b and 5 times the base, the area would be 5b squared, and the base is simply the difference between the two functions. How far apart the base is gives us, or how far apart the functions are tells us the base. So to get the volume, we integrate. It would still be 0.239 to 1, and it would be square root of x minus e to the negative 3x squared. Okay? Now, it's important, I think, to just point out these differences, even though we've done it before and you could look back at some old videos. This is finding the area of two circles and subtracting it. This is saying the difference between the function sets the base and multiplying it by 5 to get that height component. These are very different things. They sometimes get mixed up. Be very careful not to mix those two things up. Okay. Next, find the volume of the solid generated when r's rotate around y equals negative 3. Well, if I'm rotating around something below, like something down here, what I've done is I've made the radius larger, okay, as I rotate this thing around. So let me put my answer to D right here. We're going to have pi multiplied by the integral. The bounds are still the same, 239 to 1. My top function square root of x, what I did was I just made the radius 3 units bigger. So it's going to be the function plus 3 is the new radius. And the smaller radius, of course, is e to the negative 3x plus 3. And that would find the volume. Okay. Finally, perimeter. I'm going to clear myself out some room to find the perimeter of R. So the perimeter actually has 3 sides, right? We've got this side and this side and this side. The straight length side is pretty easy. You know, it extends from 0.05 to 1, so it's just 0.95 units long. The other 2 sides we're going to need to integrate. So let's do this real quick because I know that we're going to need the derivatives to do arc length. So the derivative of the square root of x is 1 over 2 square roots of x. And the derivative of e to the negative 3x is negative 3e to the negative 3x. Okay. So I'm going to have this 0.95 plus an integral. Let's do the square root first, that purple line first. So it's going to extend from 0.239 to 1. We're going to use our arc length formula, so it's going to be 1 plus the derivative of square root of x, so 1 over 2 square roots of x squared dx. Plus, okay, now I'm going to do that bottom part, that green line. It's still going to be from 0.239 to 1, square root of 1 plus the derivative, which was negative 3e to the negative 3x squared dx. So it's those 3 sides. This gives you that vertical piece. This gives you the purple arc. And this last integral gives you the green arc. And the sum of those 3 things would get you the total perimeter.